Hey everyone, welcome to the Pre-algebra 10.7 video. We're talking about volume of prisms and cylinders, and I'm doing pink today. For the ladies, maybe I'll put in a little bit of purple. I understand we've been typically, masculine favored color heavy, so I figured I would try to even the playing field. Maybe we'll even do a little pastel yellow or something like that. I don't know. Well, anyway, so what's a prism? Okay, so before we move on to volume of prisms and cylinders, we need to have our definitions down. So what's a prism? So we'll remember that it's a solid that's formed by polygons, okay? Is that a polygon? That is not a polygon because it's not a closed plane, right? So that could be a polygon. It's a trapezoid. Okay, that's a polygon. It's a rectangle. What are some other polygons? Oh, a triangle's a polygon, okay? But it's only formed by polygons. These are not, in and of themselves, prisms. Okay, prisms have two congruent bases that lie in parallel planes, such as the following. All right, so what do you got there? Well, I'll use that pastel yellow I was referencing earlier. Okay, one more go to the color. All right, got a block of Swiss cheese, right? Gotta have some holes in there. Okay, so that's a prism. Now, why? Well, okay, let's talk about the two congruent bases that lie in parallel planes. You can't see the other base in the back, but we know that behind there is running, okay, that. So one of our bases is on top here, so now the cheese is moldy, and the other base would be on the bottom there that we can't actually see. And so the two bases are congruent, okay. Now they also lie in parallel planes, so if those bases were to separate from the figure and fly off the screen at you, right, they would hit you in two different spots of your face, right? Or they would never come together if these are the two bases and they moved in this direction. It's not like they would ever come and collide like that, right? They would continue on straight, all right? And the other faces, so not the bases, are rectangles, and we can see it. This side would be a rectangle, this side would be a rectangle, and that side, back there that we can't actually see would also be a rectangle. All right, so prisms. Got to be good on that before we can move on to talking about volume of prisms. All right, so what is volume? Well, volume is just the inside space, right? So otherwise known as the amount of space that an object occupies. And we talk about volume in terms of inches cubed, centimeters cubed, feet. Oh, that was supposed to finish out as a 3, it's a 2. Feet cubed, right? Or cubic inches, cubic centimeters, cubic feet. So if we had a cube, do my best to draw a cube. It's not very cubic. A little more. There we go. All right, so what we have here is a three-dimensional object. Okay, it's a cube, which is a type of prism. All right, and so we would say that probably, most likely in a cube, it doesn't really matter, but the top would be one of the bases, and that would be another one of the bases back there, which we can't actually see, but we know exists. Okay, so that's a prism. And if we're going to find the volume of a prism, we got to think about the internal space. Okay, and that is found. Okay, so volume of a prism is found by taking the area of the base times the height of that prism. Okay, so in this case, if it's a cube, then that side's going to be 4, that side would be 4, the height would be 4, so on and so forth, right? Everything is 4. So what would be the area of the base? Well, this is one of our bases, and it would be 4 times 4. Then we multiply that by our height, which our height is right there, and so that would be the blue 4. So 4 times 4 is 16 times that other 4. The volume of that prism would equal 64. Okay, but we got to think about what we're talking about here. So before I even calculated this 4 times 4, we were talking about 4 centimeters times 4 centimeters times 4 centimeters. Okay, so I want to show you something. If we were to break that up using the commutative property of multiplication, I could say 4 times centimeters times 4 times centimeters times 4 times centimeters. Okay, and then I could say, let's group what we would call like terms. So I got a 4, a 4, and a 4. So 4 times 4 times 4. And then, oh, I have a centimeters, and a centimeters times centimeters times centimeters times centimeters. So we said that 4 times 4 times 4 gets you 64. But what about centimeters times centimeters times centimeters? Well, what would x times x times x be? We'd say x cubed. So centimeters times centimeters times centimeters is centimeters cubed. All right, so when we talk about volume, we're talking about cubed. All right, and so I guess I just made it up that it was centimeters. I don't think I actually said from originally if it was centimeters. But anyway, we're going to call it centimeters, so 64 centimeters cubed. So why don't you take a minute, and I want you to find the volume of this prism. All right, so hopefully you worked on that. So it's a prism. Prisms have two bases, right? But those bases have to be, well, first of all, congruent, so the exact same area, right? Same shape. They also have to be parallel. So this is going to be one of our bases, but what's the other base? Well, he's back here, okay? And I know we got to think about that critically because it looks like the base is this, what would be a rectangle on the bottom. It looks like the, this triangular pyramid is sitting on this. And while I guess it kind of is, it's not necessarily the base. And I know it's hard because we always think base bottom, but in this case, the bases have to be the sides that are parallel to each other and congruent. Okay, so what did we say the volume of a prism was? Well, we said it was equal to the area of the base times the height. Okay, so the area of the base would be made up of, well, let's see, area of a triangle is base times height divided by 2. So we're just looking at this triangle right here. How do we find the area of that? Well, base of the triangle would be 8 times the height, and we divide all that by 2, right? So base times height divided by 2, 6 times 8 is 48, divided by 2 would equal 24. Okay, but now we have to multiply that by the height. Well, what is the height? Well, this looks like a length here, but what we want to see is that the height of a figure is perpendicular to its base, right? Okay, so if this is the base here, this has to be the height. And so we would say that's 13. And so what we do next, well, let's think. Here we took 8 inches times 6 inches and divided that by 2. So I should have done this earlier. So 8 inches times 6 inches divided by 2. So since we are finding the area of the base, this is actually 24 inches squared times our height, which is 13 inches. Okay, so automatically we know we're going to have something inches cubed, right? Because we have inches squared times plain inches. It'd be like if I said, what's x squared times x? We'd say, hey, that's x cubed, right? So it's definitely going to be inches cubed. And what's 24 times 13? Well, if you do 24 times 13, you get 312 inches cubed, or cubic inches, and that is the volume of that triangular prism. And naturally, I forgot to number again, so we'll say this little example here was item number 3. The one we just did, call it, item number 4, there for that guy. And we'll move on to item number 5. And item number 5, we're talking about volume of a cylinder. Okay, so again, what's a cylinder look like? Let's make sure we have that, right? Okay, and it has volume, it's a solid, so it's got some space in there. And it's actually, the formula for volume of a cylinder is basically the same as the volume of a prism. We're going to find the area, okay, of one of the bases, and we're going to multiply that by the height, which would be that right there or that right over there, okay? So times height. All right, so maybe you have a circular pool, maybe you have a dog that likes to, swim in the pool, such as that. And if he does, we want to calculate the volume of the dog's pool, which has now become the dog's pool and not yours for whatever reason. Okay, so how do we do that? Well, I'm going to kind of redraw this pool, And we'll put our dog up there for right now. And we know the pool's a cylinder, right? It's a circle area on top, circular area, and it's deep. Okay, so I'm going to kind of draw some sides right there and like that. Okay, so what we need to know are a couple things. Okay, we need to know either the diameter or the radius of the pool, and we'll say that the diameter is 18 feet. Okay. And how deep is the pool? We'll call it a 4-foot deep pool. Okay. So how do we calculate the volume of that? Well, remember, the volume of a cylinder, which is what an above ground or any pool is like. It's what it is if it has, sides that are perpendicular to the top of the water, right? It doesn't cut down like that. So, maybe it has a little bit of slant in the bottom. It kind of curves down into the bottom from the side, but we're just going to get approximate here, okay? So the volume of a cylinder, again, is the base area, or area of the base, times the height. So what are the bases? Well, the bases are going to be the top and the bottom, right, are circles. And so we need to find that base area. So how do we do that? Well, area of a circle is what? Pi r squared, right? So to find our base area, we're going to take pi times our radius, which, well, if the diameter is 18, the radius is 9, and we're going to square that, okay? So that'd be like saying pi times 81, okay? And when you type in 81 times pi, what you get is 254 point, we'll round to the nearest tenth 5, okay? But keep in mind, we are talking about area, right? So it's feet squared, okay? Now all of that, though, is going to be times the height. So the height is easy because it's 4, right? Comes right there. So times 4, so 254.5 times 4 equals 1,018, and remember, it was 4 feet. So feet squared times feet is feet cubed. And that right there is the volume of that pool. Now, one of the cool things we can do, though, is say, okay, well, pools, when we talk about the volume of pools, we usually don't talk about cubic feet. We usually talk about gallons, like how many gallon pool, right? How many gallon fish tank or something like that. So what we can actually do is use a conversion factor to figure out how many, not cubic feet, but how many gallons, all right? And so there's a conversion factor out there that goes from gallons to cubic feet, and it says that 7.481 gallons is the same as 1 foot cubed. All right, what does that mean? Well, it means if you had 1 cubic foot of water, right, so that would be 1 by 1 by 1, and it would take, let's see if I can do my best to draw a milk jug. That's a terrible milk jug. But anyway, if these are all 1 gallon, it would take 7.481 of these to fill this up, okay? So how are we going to take this and go from cubic feet to gallons? Well, we're going to use this conversion factor. So we're going to take our 1,018 feet cubed and multiply it by this conversion factor. Now, we can put any number over 1, so now we're multiplying a fraction by a fraction. And conveniently enough, we have feet cubed on top, feet cubed on bottom, so they cancel each other out. So now we're taking 1,018 nothings, okay, times 7.481 gallons. And we'll look what you get. On top, you get 7615 we'll round 7 gallons over 1 times 1, nothing, so it's just 1. Or we could just say it's a 7,615.7 gallon pool. All right, guys, that's all I have for you. I'll see you in class.